Good day everyone. Today we're gonna solve a problem on Fluid Mechanics Chapter 5, Fundamentals of Fluid Flow. So in this chapter we are dealing with fluids that are in motion, unlike the previous chapter which we deal with fluids that are static. This chapter also is also based on the principles of conservation of energy, conservation of momentum, and principle of energy. So let's start. A syringe with an inner diameter of 4.5 cm contains a fluid inside with a specific gravity of 1.3. If the plunger was pushed at a rate of 0.03 meters per second, what is the velocity of the fluid coming out of the needle if the inner diameter of the needle is 0.5 millimeters? Also, what is the weight flow rate of the fluid? So here in our diagram or illustration, we have the inner diameter of the cylinder, which is 1.45 centimeters. We also have the inner diameter of the needle, which is 0.5 meters. We also have the velocity inside of the fluid inside the cylinder or inside the syringe, which is 0.03 meter per second. And we also have the specific gravity of the fluid. So first, we need to write all the givens we have. And as you can see, the measurements are not in the same units, so we need to convert them into the same units. So I converted them to meters, and 1.45 centimeter is equal to 0.0145 meters. 0.5 millimeters is equal to 0.0005 meters. So to solve the velocity of the needle, or rather fluid inside the needle, we need to put in our minds that we are dealing with continuous flow. So the discharge in the cylinder is equal to the discharge inside the needle. So Q1 is equal to Q2 based on the continuity equation, and discharge is equal to area times velocity. So we are going to convert this equation into A sub 1 V sub 1 is equal to A sub 2 V sub 2. And to solve for the area is equal to pi squared over 4. And we have constants on the same sides of the equations here, so we can cancel these constants, we can cancel the pi, and we can cancel the 4. So what will left in our equation is d sub 1 squared times v sub 1 is equal to d sub 2 squared times v sub 2. And these variables in our equations have the values in our given, and we are looking for v sub 2, so we need to isolate v sub 2 on one side of the equation. So we divided both sides of the equation by d sub 2 squared, and cancelling d sub 2 squared on, we have v sub 2 is equal to d sub 1 squared times v sub 1 is all over d sub 2 squared. And all the variables here on the right side of the equation has values in our given, so we just have to plug in all those values. So simplifying the equation, we have v sub 2 is equal to 25.23 meters per second. And this is the final answer for the part A of our problem. In part B, we are asked to calculate the flow rate of the fluid. This is a flow rate inside the needle, so flow rate is simply equal to gamma times the discharge. And we don't have the value of gamma, but we have the value of the specific gravity of 1.3, which will be used to calculate the specific weight or gamma of the fluid. So we'll just need to multiply its specific gravity by the specific weight of water, which is 9.81 kilonewtons per meter cube. And the discharge is equal to area times velocity. You can either use A sub 1 or V sub 1 or A sub 2 times V sub 2, but in this problem I'm gonna use A sub 1, V sub 1, and to find the value of A sub 1, area is equal to pi d squared over 4, and plugging in the value of d sub 1, which is 0.0145 meters, we now have this equation. And now simplifying this, we have the value of the weight flow rate of the fluid, 0.000063 kilonewtons per second. And this is the final answer for the second part of our problem.